In Chapter 4, Section 3, we had those long proofs where we had to prove triangles are congruent. And in 4.4 and 4.5, we're going to have some shortcuts for proving triangles are congruent. And right here, we have all combinations of sides and angles. This means side, side, side. This means side, angle, side. This means side, side, angle, 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 side, angle, and angle, angle, side. And the question is, does it matter where the A is, if it's between the S's or not, or if the S is between the A's or not? And it does. The included angle is the angle formed by two adjacent sides. So right here, this would be B, that would be A, and that would be C. B is the included angle between the segment AB and the segment BC. So this would be side, angle, side. And you're going to have the side of the triangle over here that really it's not marked, we don't know anything about it. So this would be considered side, angle, side. And the included side is the side formed by two adjacent angles. And this time we have angle P and angle Q, and then we have the segment PQ. So this one would be angle, side, angle, and we can connect this up here to form a triangle, but these are the only three things we know: angle, side, angle. And we said this one up here would be side, angle, side. So we have these 6 combinations right here, and the question is, do all 6 of these combinations work? So to test this, if I give you 3 angles, 30, 70, and 80, and tell you to draw a triangle, would everybody draw the exact same triangle? Well, I'm going to start right here, and I'm going to draw. This will be my 80 degrees. So right here is 80. And then right here, I'm going to draw 70. So I start at 0 and I go up to 70. And then if we connect those, do they end up, there's our triangle, sorry. This is 80, this is 70, and this one is forced to be 30. And just to double check it, it's right there on the 30. Now I'm going to draw another triangle over here, and we're going to see if it's equal. And I'm going to start with base, just like I had last time. And I'm going to make this angle right here 80 degrees. And I'm going to make this angle right here 70 degrees. Perhaps I went a little overboard in proving my point here. So this was 80, this was 70, and this was 30. Hope you can see that. If we have angle, 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 do these triangles have to be congruent? And I hope you can see by this picture that these triangles are not congruent. So no, all combinations do not work. And I will tell you that angle, 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 and side, side angle do not work. The other four do work. So up here, I'm going to cross out angle, 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 side, side angle. And these other four combinations are all ways to prove triangles congruent. And we have this kind of listed on the next page. Side, side, side. If three sides of one triangle are congruent to three sides of another triangle, then the triangles are congruent. And here we had these sides congruent, these sides congruent, and these sides congruent. So this one would be side, side, side. The next one, if two sides and the included angle are congruent. So right here we have a side congruent to a side, the angle congruent to the angle, and then the side congruent to the side. And sometimes I think it helps to label these with S's and A's. And see how we have this part here that isn't marked with anything? You can start on either side of that. So this is the unmarked part, and then you would have side, angle, side. The next one, angle, side, angle. We know this angle, this side, and then this angle. So we have angle, side, angle. And I guess I should read this. If two angles and the included side of one triangle are congruent to two angles and the included side of another triangle, then the triangles are congruent. So in this case, the side is between the angles. The next one is angle, angle, side. And the thing that's tough about this one is right here, we don't know anything about this side, but we know this angle, and that side. And sometimes I like to put an X here. We don't know anything about those two. So you can start either here and have angle, angle, side, or here and have side, angle, angle. And this special property works only in right triangles. And this is if you have the hypotenuse and one of the legs congruent to the hypotenuse and one of the legs, then your triangles are congruent. On this next page, we're just trying to figure out which theorem tells us the triangles are congruent. And with the first one, you could get that side congruent to itself. And what we're saying is the right-hand side of that triangle is congruent to the left-hand side of that triangle. So this would be a yes by side, side, side. Right here we have parallel lines. So we can say our alternate interior angles are congruent. BD is congruent to BD by reflexive. And sometimes it helps to take like a colored pencil or a different color and trace the things you do know. And in this case, you have a side, an angle, and then a side. So that would be yes by side, angle, side. Number 3, we have to do some vertical angles here. Vertical angles are congruent. And then in that case, if you color in what we have, right here you have a side, then an angle, and then an angle. So you could either call this side, angle, angle, or angle, angle, side. Number 4, it's kind of hard to tell. We've got these angles congruent up here. Down here we have some angles congruent. And we can get that piece is congruent to itself by reflexive. So this will be side, angle, side. Number 5, we have some vertical angles right here. So we have side, angle, side. Number 6, they give us enough information. Side, angle, side. Number 7, we could get these two congruent by reflexive. And we could get these two angles congruent because they're both right angles. But we really only have those two pieces of information. So those two are not congruent. Number 8, that would be congruent to itself by reflexive. Those would be congruent by alternate interior angles. But we only have those two pieces of information. So those two are not necessarily congruent. Number 9, we have a right angle. So those angles can be congruent. We have this side congruent to this side. And if you look at this triangle, WX is the hypotenuse. And if you look at this triangle, WX is the hypotenuse. So since we have a right angle, we have the hypotenuse congruent to the hypotenuse, the leg congruent to the leg, and that will be hypotenuse leg. Number 10, we're given that those are congruent. And this one we can do a couple different ways. Since we have these parallel lines, you could say that those are congruent. And since we have the parallel lines, you could also say that those are congruent. And then you have angle, angle, side, or side, angle, angle. And you also could have done that with some vertical angles and done that a second way. Number 11, this piece, the right-hand side of that triangle, is congruent to the left-hand side of this triangle. So these are congruent by side, side, side. Number 12, we have some right angles. Hypotenuse congruent to a hypotenuse. That side is congruent to that side. So that will be hypotenuse leg. Number 13, we have a right angle congruent to a right angle. Hypotenuse congruent to a hypotenuse. A leg congruent to a leg. So that would be yes by hypotenuse leg. Number 14, you can get this piece congruent to itself. And then you have angle, angle, side. And 15, you can get BC congruent to BC. So you will have side, angle, side. Couple more on the next page. Right here, we're going to have a reflexive one. So this will be angle, angle, side. Number 17, those are congruent by reflexive. So So you will have side, side, side. Number 18, you're going to have to get some vertical angles here. Angle, side, angle. Number 19, you can say vertical angles are congruent and write down what you think that one is. That one will be side, angle, side. Number 20, we can get these two congruent by reflexive. And this one is kind of a trick question. If we label what we have angle, side, side, which does not work. That's one of the combinations that does not work. And I prefer to write side, side, angle in the other order, and that one does not work. So they are not congruent. There's actually two different triangles that you can draw for side, side, angle, so that does not prove the triangles are congruent. Number 21, you can get that piece by reflexive, and then write down what you think you've got, and you would have side, angle, side. Try 22 on your own a minute. You would get that by reflexive, and then you would have side, side, side. Now 23, we have this piece congruent to this piece, that piece congruent to that piece. So all you have is two sides that are equal. So there's not enough information there to prove that those are congruent. 24, you could say that LN is congruent to itself. And you could say that those are congruent to itself. And you don't have anything else there that you can say is congruent. So we cannot prove those are congruent because there's not enough information. 25 and 26, we can prove they are congruent. We can get that side equal to itself, and you will have angle, angle, side. 26, you would have that side congruent to itself, and we would have angle, angle, side. And 27, we could get that piece congruent to itself. We only have that angle and that side, so those are not congruent or not enough information to prove they are congruent. 28, you are asked to find x, and I am going to look at PQ, which are the first two, and that's going to match up with MN. So PQ is x plus 2, MN is 7. Those are corresponding sides, and if you subtract 2 from both sides, x equals 5. And 29, you could either set these sides congruent or the angles congruent, and I'm going to do the angles congruent. 2t squared equals 32. You're going to divide both sides by 2, and you would have t squared equals 16. And then square rooting both sides, t would equal 4.